Okay, so we have just discussed all of the different properties of a solar system that we're looking for. So, a guy by the name of Drake came up with the Drake equation, which is going to tell us what the probability is of life in our galaxy. And so, the first step is to figure out how many planets there are in our galaxy. So let's just make an assumption. Well, first of all, do you remember the number that I gave you for the number of stars in our galaxy? Okay, it was 100 billion. Okay, so we could write 100. Okay, so that would be 100,000, and then 100 million, and then 100 billion. Right? So that's the number of stars in our galaxy. Okay, now how many, just take a guess, how many planets do you think are in orbit around each of those stars? Well, ours, we have a whole bunch of planets in orbit around our star. So let's just say, for the sake of argument, that there are 10. So around each of these 100 billion stars, let's say that there are 10 planets in orbit around each one. So that means that we need to add an extra 0. So then this would be the total number of planets that could have life in our galaxy. Now we're just talking about our galaxy. So there is roughly 100 billion galaxies in our universe. But let's just concentrate on our galaxy. So that's the number of planets that we've got to work with. All right, so now let's start to whittle them down. So you'll notice that the first percentage that we need to have is what is the percentages of solar systems that have one star. All right, so do you remember that I said that approximately 50% of all the stars in the night sky are one-star solar systems? And then we said that about 40% were binaries. Okay, so that means that we could take this number and divide it by 2. All right, so if we did that, if we divide this by 2, then that changes this to a 5, and then we can get rid of one of those zeros. So now we're down to this many one-starred solar systems in our galaxy. Okay, then the next one is that the star has to be the right size. So it can't be a blue one, but it could be yellow and it could be red. So we need to know what's the probability of yellow stars, red stars, and then blue stars. Well, those blue stars actually are not that common. So let's say there's I'm just going to keep this easy again. Let's say there's a 50% chance that it's the right star. Okay, so that means I need to take this then and divide it in 2. Okay, so now we're down to here, 25, and then get rid of another 0 over here. So now we're down to this many possible candidates in our that we're looking for. Okay, and so then the next category is that it needs to be the right-sized planet. So it needs to be the right-sized planet. So it cannot be a Jupiter-sized planet, and it cannot be a Mars-sized planet. It has to be an Earth-sized planet. So if you look at the planets in our solar system, like for example Mercury is too small, but Venus and Earth are the right size. Okay, I'm going to say there's only a 10% chance that our planet is going to be the right size. So that means that we can get rid of another 0. Okay, then the next thing is, well, what about the distance? Is it the right distance away from the sun. So if it's too close, it's going to be too hot. If it's too far away, it's going to be too cold. So it's got to be the right distance. So what's the odds that our hypothetical planet is just the right distance? I'm going to say 1%. Okay, so that means I can get rid of a couple of these. Okay, and then what's the odds that our solar system has a planet like Jupiter that's going to help to act like a shield? Well, that's pretty high. So I'm not even going to do anything. So I'm going to say most solar systems are going to have a gas-like giant. So I won't even bother to take off a 0 or anything on that. What about the moon? So it's got to have the right sized moon in orbit around it. If you look at the moons that are in orbit around most of the objects in our solar system, you notice they're pretty small in comparison to the size of the planet that they're in orbit around. Earth is the exception. So I'm going to say that only about 10% of the planets are going to have the right size moon. So that means I can get rid of another 0 on there. Okay, and then, okay, what's the next thing? So chances that life evolved on the planet at all. So what's the odds that it's going to have any kind of life whatsoever? Okay, I'm going to say a 10% chance. So even if it's got bacteria, let's say that there's a 10% chance that bacteria could be on the planet. Okay, so we'll get rid of another 0. So now we're down to 2.5 million possible planets. All right, now what's the odds that the life has evolved up to us? So something that is intelligent. What's the odds that that has happened? Not so good. All right, so I'm going to say that maybe a 1 in 1,000 chance that intelligent life has evolved. So I'm going to get rid of these 0s. So now we're down to 2,500 planets in our solar system, in our galaxy, that could have intelligent life. And now this last one. Okay, so how long have we as humans had radio communications so that we've been able to communicate with other people? Okay, we've only had radio communications for like 100 years, 150 years at the most. Okay, so how long have humans existed? So we think that humans have existed for about, modern Homo sapiens, let's say we've existed for 100,000 years. So out of that 100,000 years, we've only had radio communication for 100 years. And so imagine that on these other planets, if they're not so evolved, they might be Neanderthals, and they couldn't communicate with us even if they wanted to. They might be so far advanced that they don't want to communicate with us. So what's the odds that their level of technology is the same as our level of technology at this moment in history? Not very likely. So probably, again, 1 in 1,000, so that now we're at 2.5 civilizations. So that in our galaxy, there might be 2 to 3 civilizations that are as advanced as us and want to communicate with us. Okay, so now what's the problem? So our galaxy is 100,000 light years in diameter, and those 3 civilizations could be anywhere in the galaxy. So that means that if they start sending out their radio waves, how long is it going to take to reach Earth? It could take hundreds, maybe thousands of years. So that even if there are intelligent life in our galaxy, the chances of us communicating with it is pretty slim. Until, of course, we get warp drive. And then we can go faster than the speed of light. And then it's like Star Trek, and we are exploring brave new worlds. All right, now I would encourage you to do these same calculations with your own numbers. So you make up numbers and see what you turn out. So I've had students that have said that there's 1,000 civilizations in our galaxy. I've had other students that say that there's 0.1 civilizations. So what does that mean? None. So if it's less than 1, then that means that there's no other civilizations in our galaxy. So I encourage you to go ahead and do it. All right, so if we are going to communicate and we don't have warp drive, how are we going to do it? So we're going to have to contact them using radio waves. Now we could build rocket ships, and we can send rocket ships out in every direction and hope that we hit one of these planets. But the best way is to send out radio waves in all directions. And so we've been doing this. So this is called Arecibo, and so this is an island down in the Caribbean. It's no longer in operation. That radio antenna thing there, it collapsed into the bowl, and it destroyed the telescope. But we were sending messages into outer space. And so what was the message? So this is called the Arecibo message, and it consists of 1,679 bits of information, dots and dashes. Now, what an alien civilization is supposed to recognize is that 1,679 is equal to the product of two prime numbers, the prime number 23 and the prime number 79. So a prime number is a number that you can't divide it by any number and get a whole number. So like, for example, 4 is not a prime number because 4 can be divided by 2. But you can't take 23 and divide it by any number and get a whole number. So it's called a prime number. So this alien civilization is supposed to see 1,679 pieces of information and say to themselves, oh, well, that's 29 or 23 times 79. Okay? Then they're supposed to recognize that if you take 23 going this way and 79 going up, then those 1,679 bits of information make a picture. That's the picture. Now that picture's in color. The picture would be in black and white. But that would be the picture that would be produced if they put it in the correct order. So what does the Arecibo message say? So up at the top, it gives you the numbers from 0 to 9 in binary. Okay? Then underneath it, it tells you what are the main elements found in life. So it was oxygen, carbon, and hydrogen. So it gives the atomic numbers of the main elements that are found in life. Okay, then underneath that, it's going to tell you what are the nucleic acids that are found in DNA. So then it gives you the chemical formulas for the nucleic acids that makes up DNA. Okay, then if you go underneath that, it shows you a picture of what DNA looks like and tells you how many nucleic acids are in human DNA. Then underneath that, it gives you a picture of what a human looks like. It gives you the height of a typical human. It also tells you how many humans are on Earth. So it gives the population of Earth. Underneath that, it shows you a picture of the solar system. So do you notice that it has a picture of the sun, which is the biggest one, and then it has Mercury, and then Venus, and then you notice that Earth is highlighted, and then you got Mars, and then Jupiter, Saturn, Uranus, and Neptune, and then even Pluto is on there. And then underneath that is a picture of the radio telescope that was broadcasting the information. And then underneath that is a caption that says, "Humans are tasty, come and get us." Okay? No, it doesn't really say that. So the last one actually is telling you the frequency of the radio beam. But the point is that there are some astronomers that say we should not be advertising that we're here until we get warp drive, we get deflector shields, we get phasers, and we get photon torpedoes. Okay? So until we can defend ourselves, we really should not be telling other alien civilizations where we're at, because you've all seen Independence Day, and so you know what happens when alien civilizations that don't like us show up on our doorstep. Okay. Well, that is it. So we are now finished with our tour of astronomy. And so if you will come back, we will take our final quiz for the course.